Hello everyone, welcome back to my YouTube channel. So in this video we are going to see how we can attach EBS volume inside our EKS pod or application pod. So this is the project structure which we are going to follow. So we have total 5 files or 5 YAML files which we are going to run. So the very first YAML file is eks-cluster-creation.yaml. So basically as part of this file we are going to create our EKS cluster with worker node. Second file is ebs-storage-class.yaml file. So from this file basically we are going to create our custom storage using AWS EBS CSI driver. Third file we have is persistent volume claim pvc.yaml file, which basically we are going to create persistent volume claim basically with the help of this file. Fourth file we have here is pod.yaml file. So this file basically we are going to use to deploy our application, basically nginx application we are going to deploy, and on the nginx pod basically we are going to attach our persistent volume claim, or we can, in simple words we can say, we will attach our EBS volume inside this application pod. Fifth file is ebs-app-service.yaml file. So here basically we are going to create a load balancer service so we can access our nginx application from DNS name or from our local system. So let's see all of these 5 files, what all the contents it has. So let me close this and let me open my Visual Studio Code. So here we have very first file which is ebs-cluster-creation.yaml file. So this is very a simple file. So here we have defined a API version which is eksctl.io/v1 alpha 5. So this is the API which we are going to use, and this complete demo we are going to perform with eksctl utility. Now we are going to use eksctl utility. So kind is cluster config. Metadata, here we have to define a cluster name from like which name you want to create a EKS cluster. The region, so I am going to use AP South 1, and this is the this is the basically OIDC provider which we are telling here, okay, I want to enable OIDC provider as well. Now as I'm recording today, it's 2025 June. So now I can see AWS also introduced a new utility called pod identity. So if you want, you can use pod identity as well. But here we are going to see a OIDC. What you can do, if you are going to use OpenID Connect as well, and you can later migrate from OIDC to pod identity as well. So that agent basically run in your worker node. So that we will see in a demonstration as well. And another, we are going to create EBS CSI driver add-on. So basically we are adding a EBS CSI driver add-on, and here we are referring this policy. So mhon EBS CSI driver policy. So this is required for identity and access management. So that's why we are going to attach this policy, and it is required as well. Then we have another part here is node group. So the simple here we have to define a name of our node group. So ng-1. What kind of instance you want to use in worker node. So I'm going to use t3.medium. Then desired capacity I want 1, and volume size, root volume size basically. So I have defined here 20 GB. And if you want to allow SSH connection on your worker node, you can do that. So for this demonstration I have put okay, allow it. So this is the very simple YAML file which we are going to use to create our EKS cluster. Another file here we have is EBS storage class. So here basically we are going to create a custom storage class. So the API version is storage-k8s.io/v1. Kind, we want to create a storage class, so the kind will be storage class, and under metadata the name of our storage class EBS-sc, and this name basically we have to reference later in PVC file as well. And provisioner, we are going to use ebs.csi.aws.com. So this is the provisioner. Then these are the parameters, because if you don't want to use a custom storage class, then by default AWS create a storage class for you, and that will create it by like general purpose 2, which is older versions. That's why we are going to use here, create here custom storage class. So you have a lot of controls on it. Then we are going to use your volume winding mode, wait for first customers. So it basically wait until your pod is scheduled, like before provisioning the volume. Once your pod will be scheduled, then only it will create a persistent volume as well. So then here we have again a reclaim policy, so which is delete. So delete the EBS volume when the PBS is deleted. So when our persistent volume claim will be deleted, automatically the this storage class will also be deleted. Sorry. So here we have multiple options. If I'll go back to my presentation. So okay, let's first understand here storage. What is storage class? So basically storage class is a blueprint that tells Kubernetes how to provision storage when a pod asks for it via a persistent volume claims. And persistent volume claim basically is nothing, it's just a request which is raised by application pod or Kubernetes pod. And persistent volume is the actual storage resources, so like your EBS volume. So these terms you have to keep in mind. And here I just want to show you why defining a custom storage class using the AWS EBS CSI driver is important, even if a default exists. So we already, if we will not use a custom storage class, then we will by default get like whatever the AWS provided, that storage class we can still use it, but you will not have a control over it. So these are the benefits I have listed here. So the very first thing, optimize cost and performance. So the first thing is volume type. So if you are using a custom storage class, you can define a GP3, which is general purpose 3, instead of older version, which is general purpose 2. And if you are using GP3, definitely you will get a better performance and cost efficiency as well. And you can also use custom input output as well, IOPS throughput basically. So you can do that also, because there are a lot of parameters which you can specify as part of custom storage class creation. Then in the reclaim policy, so we have two options, delete and retain policies. Like if you want to auto delete a volume when a PVC is deleted, you can choose a delete policy. So if I go back to my Visual Studio Code, so here we are going to use delete, because this is a demonstration, so we don't want to retain that volume. So that's why I have defined a reclaim policy here is delete. Another option here we have a retain as well. If you want to retain a PVC after, if you want to retain a volume after deletion of your PVC persistent volume claim, then you can use a retain option here. Instead of delete, you can put a retain. Another feature we have here is ensure availability zone consistency, because when we create a EBS volume that are bounded to your availability zone. So if it is if it is creating by default whatever the AWS is going to create, in case if you have, like if something goes wrong or it's misconfigured, then you can see errors as well. And wait for first customer we already discussed. So ensure volume is created in the same availability zone as the pod, preventing attachment issue. So that's why we are using here wait for first customer. So once the pod is scheduled, only then it will basically attach the EBS volume to it. So that's why we are going to use this particular parameter, wait for first customer. So now another file here we have is persistent volume claim. So again the API versions, kind, persistent volume claim. So everything, all these parameters you can easily find on our documentation as well. AWS, they are very good documents. So I have followed that document itself. So the metadata name here is EBS PVC. So any name you can give here. So I have just given EBS-PVC for understanding or simplicity purpose. Then here we have specifications. So under that we have multiple options, access mode, read write once. What it means basically, so EBS volume support only single node access. So whatever the EBS volume you will create, that at a time it will only attach to a single, or it will basically support single node only, not multiple node. And this is the storage class name we are referencing here, EBS-SC. So if I'll go back here, storage class, so this is the name we have defined here, EBS-SC. So same name, because we need to reference the storage class. Okay, which storage class we are going to use as part of our persistent volume claim. So we have to reference it. So that's why I have reference here. And under resources, you can define, okay, how much space you need, 5 GB, 10 GB, 20 GB, 100 GB for your persistent volume. So for that, I have defined here simply 5 gigabyte. Let me close this file. Another file here we have application pod. So again, the API version is v1, kind will be pod, because we are going to create an application pod here or Kubernetes pod here. Metadata, the name you can give, like I have given a name EBS-app, so you can give any name, and I have created a label also. So app is equal to EBS-app. So you have to keep in mind, like whenever you use a labels, because these you are going to reference later in service.ml as well. So if I'll quickly go to service.ml file, here if you can see, so selectors I have defined mentioned EBS app, because that's how Kubernetes will know, okay, I need to forward the traffic to on this particular application pod. So that's why we have to keep these labels and selectors keep in mind. Okay, let me go back to my pod.ml file. So and this is the specification of application. So the container name is app, image we are going to use nginx latest image, and as we know, nginx by default use port 80. So here we have defined port, under port we have defined container port is 80, and here basically we are going to add a volume mount. So this is the mount path which we are going to create inside our pod or inside our container, and we are going to give a name is EBS volume. And this is the volume basically which we are going to link, the persistent volume claim which we have created under 03, that we are going to reference here. Okay, so mount this path of my container from this persistent volume which we have created. So here we have defined a name under volumes. This is the name of our EBS volume and persistent volume claim. So the claim name is EBS-PVC. This is what we have created. So if I'll go back to my 0.3, so this is the name of our persistent volume claim. So same name you have to reference inside your pod.xml file, sorry, pod.ml file. Okay, last file we have here is ebs-app-service.ml file. So again, API version v1, kind will be service, because we are going to create a service here. You can give any name here. Specification, you have to select a correct selectors. So here I have used ebs-app, and port TCP protocol we are going to use TCP, port 80, target port will be 80, and the type we are going to use load balancer, because we want to access our application from our local system using a DNS name. So these five files we are going to run as part of this demonstration. Now let me go back and let me open a terminal here. Okay, so before that, let me do one thing. Let me go to my AWS console and let me go to IAM user, because for the authentication purpose we need any user which we are going to use. So I have already one user which we are going to use. So demo user we are going to use, and for this user I have defined a permissions. Let me see the policy. So this user has administrator access, like it can do all of the operations, but it is not recommended if you are going to use in a production level or somewhere. You have to always follow a fine grain control basically. So whatever the permission is required, only those level of permission you have to provide. But this is a demonstration, so I have just provided a full permission here. So now let me go to security credentials and let me create an access key. So I already have a one access key, but I don't know the password. So let me deactivate the existing one, and let me delete it also. Okay, so now let me create a new access key. Okay, where it is. Okay, so I'm going to use case is command line, because we are going to use AWS CLI here. And one more thing, I have already installed all the prerequisites like eksctl utility, AWS CLI, kubectl. So everything you should be installed in your local system. So let me click on create. Okay, let me copy the access key and paste it in Notepad. Okay, let me copy the secret key as well. Okay, let me click on done. So this user we are going to use to create our EKS cluster. So now let me go to my terminal. So the very first thing we have to run AWS configure command. Sorry, the spelling is mistake, I think. Okay, it's correct. Okay, so now let me provide my access key here, and this is the secret key. Region is AP South 1, that is fine, and default output format, I don't want any format, so JSON will be default. Okay, so we are authenticated to AWS. Now let me clear the screen. Now the first file, which is EKS cluster creation, so the very first thing we have to create a EKS cluster. So let me run the first file. So for that I will run a command eksctl create -f and 01. Okay, so sorry, it's not eksctl. Let me sorry, I think here I have forgot to mention a cluster, so let me clear the screen. eksctl create cluster, and then we will provide a file name which is 01. Okay, so you can see we are getting a okay, so this is the basically version we are going to use 1.32 I think by default, but here we are getting a warning from version 1.33 onwards. Amazon EKS will continue to release AL23. Okay, just ignore it, this is not required. So something is going to change as part of our EKSCTL, but it is fine. So what is happening basically in background, this eksctl command which we have run, that is basically going to launch a CloudFormation stack. So if I'll go back to my console, and if I'll go back to a CloudFormation, so it's similar to a Terraform in simple words, if I would say. So this is the command. So basically let me minimize this. So if I'll go to event, so you can see what all the resources it is going to create as part of this command, eksctl command. So you can see a lot of resources it is going to create for you. And if I'll go to resources, so here, so you can see all the resources which is going to provision as part of this command. So this eksctl command which we have just executed, that is going to take a couple of minutes, I think maybe 15 to 20 minutes. So what I will do, I will pause the video. Once the EKS cluster will be ready, I will resume back. Okay, so our EKS cluster is ready now. We can see a message here, EKS cluster, the name of the cluster in this region is ready. So if we need to verify, let me let me run the command eksctl get cluster. So you can see we got a name of our EKS cluster. So here we are seeing a one warning here. So instead of using OpenID or OIDC connect, sorry, actually there are two warnings. Let me first explain this. So here we are getting a first warning. It's regarding to OpenID connector. So this is the identity provider which basically help to application pod to access the resources like EBS volume, S3 service. So eksctl use OIDC, but now AWS has introduced another or I would say an enhanced version or enhanced way to associate this. So we can use a pod identity association as well. So if you are already using a OIDC with your Kubernetes cluster, then you can migrate it to EKS pod identity as well. So for that, basically you have to run migrate command. And if I'll go to my demo.md file, so here we have a command. So let me minimize this first. Okay, so to migrate your EKS cluster to use your pod identity, so we can simply run the single command. So what it will does, basically it will migrate the identity provider from OIDC to pod identity basically. So if you want, you can do it. So basically what this command will do, basically it will install the EKS pod identity agent on your worker node basically. So if you want, you can run this. Let me do that. So it will again take some time. So let me clear it and let me okay, it's gone. Let me control. Okay, so let me clear the screen here and let me run the command. Unable to describe a cluster control pane. Okay, so region is correct. This no cluster found for the name demo EKS cluster. Okay, let's quickly check the cluster name. So we have given a cluster name, my EKS cluster. Let me copy it. Let me change it here. Okay, so now let me run this command. So this will basically migrate your identity provider. So now your application pod will use a pod identity instead of OpenID Connect provider. So again, this will take a couple of minutes. So let's wait it. Let's wait. Once this will be completed, I'll be resume back. So you can see it is going to create an add-on, identity add-on. Like, so if you want, you can use this pod identity add-on during the cluster creation as well. But I just want to show if somebody is using OIDC identity provider, in that case how he can migrate it from OIDC to pod identity. And the latest as of now is pod identity. Like, you should use pod identity instead of EKS, sorry, instead of OIDC identity provider. So what one more thing, whatever task basically we will execute using eksctl, this command always use a cloud formation. So if you can see here, it is again launch a new stack with the name of EKS cluster add-on bpc-cni. So if I'll go to my cloud formation here and I'll go to stacks, let me refresh it. So you can see it is again created a new stack. So everything will be performed while backend from using a cloud formation only. So okay, let me go back to my terminal. So it's completed now. So let me clear the screen. Okay, and let me close this file as well. So the next command, or sorry, our next file is EBS storage-class.ml file. So now let me run this file. So for this I will use kubectl apply -f and I will pass 02. So this basically is going to create a storage class. So storage class has been created. And one more thing, if you need to verify the EBS, the EBS CSI driver is it's installed or not, so you can test it. Let me copy the command to verify it. Okay, so this is the command from which we can verify if EBS CSI driver is available or not, or installed or not basically. Okay, no resources found in the kube system. Okay, it's drive CSI, sorry, let me show driver. So we can see the pods are running, so it means the EBS CSI driver is successfully installed or added in our Kubernetes cluster. Okay, so now let me clear the screen again. So we have created our storage class with the help of this second file. Let me close this one. So now we need to create a persistent volume claim as well. So for that, again I will run kubectl apply -f and the file name, which is 03 in this case. So the persistent volume claim is also created. Now the next thing, we need to create an application. So we will run a pod.ml file. So let me 04. Okay, so now let's verify we are getting pods cube kubectl get pods. Okay, so container is creating, so it will take maybe a couple of seconds more. Let's wait. Okay, so let me rerun the command again. Okay, so the EBS app, this is the pod name which we have defined, it's running fine. And also if you want to verify your persistent volume also, so you can use kubectl get pvc command, simple. So you will get list of your persistent volume claim which you have created. So you can see this is the name of our persistent volume claim, and this is the volume, and capacity we can give 5 GB, access mode, storage class, and volume attribute we are seeing as unset, because once the pod is scheduled it will attach it. And to verify this 5 GB EBS volume, we can verify from our console itself. So if I'll go to EC2, and here if I'll go to volumes, so here we will see two volumes. One, the root volume for our node group, which we have attached 20 GB. So you can see a two volume 20 GB size, which is used for node group or worker node, and the 5 GB volume for our EBS volume, which we are going to use or we are going to attach in our application pod. So if you minimize this, so here you can see that detail as well. So this volume is attached to a node, and this volume will be attached to an application pod. Okay, let me go back to my terminal. So okay, application pod is also running. Now let's run the fifth file, which is load balancer service. So let me change it here. So now we will run 05 and kubectl get sbc. So this is the external IP or DNS name from which we can verify our application is working or not. So if I'll take this DNS name or external IP, and if I'll go to my browser again, okay, so here let me search HTTP. Okay, this site can't be reached, so let's wait a couple of minutes. So we are seeing here DNS problem, but it will automatically resolve in a couple of minutes. Let's verify the pod status as well. kubectl get pods. Okay, so pod is running. Okay, why it's not working? Let's wait again a couple of seconds more. Let's try HTTPS. HTTPS won't work because we have not used SSL. Let me close it. Okay, so now we are able to see a Nginx homepage. It means the application pod is working fine. Okay, now next thing, we need to see the volume. So for this, let me go to this file and let me clear this screen as well. Okay. Sorry, let me describe the pod. kubectl describe pod. Pod name is EBS-app. Okay, so here we can see under volume, we can see the volume name, which is EBS-volume, and this is the persistent volume claim. With this name only we have created. And if I'll go to mount path, so you can see the mount path also is created slash data, which we have created, and you can see from EBS volume. So now what we can do to verify this, we will basically create some kind of files inside this data directory. So for this, what I will do, basically we are going to run a command inside our application pod. So I'm going to use kubectl exit -it, and this is the name of our application pod, and this is the text basically which we are passing to this demo.txt file, which will be created inside slash data folder. So let me copy this command and run it. So to verify if this file is created inside slash data folder or not, what we can do, we can simply list the directory. Let me copy the command. Okay, so this is the command. So if I'll run this command ls-l, so we are going to list all the directory which is inside data folder. So we can see we are seeing a file inside our data directory which is demo.txt file. So if I will delete this application pod and I will recreate this application pod, in that case this file should be available. So let me do one thing. Let me kubectl delete pod, and pod name is EBS-app. So you can see EBS pod has been deleted. So if I will run kubectl get pods, so there are no resources found in the default namespace. So it means the pod has been deleted. Now what we will do, we will again run this pod.yaml file. So it will create again a new pod for us. So let's see if this volume is going to attach or not. So let me run kubectl apply -f, and file number is 04. Okay, so EBS app -pod is created. Let me get the pods. So okay, the pod status is running now, and what we will do, again we will go and list the directory inside slash data folder. So we are still able to see a demo.txt file, and we have recreated this pod. So it means this is the basically a benefit of if you are using a persistent volume. So if you are using a containerization, in that case you have to always use a persistent volume for your stateful applications, so you will not lose your data, application data. So just want to demonstrate this particular part as part of this particular video. In case if you have any doubts, you can ping me over comments. I will list all these command inside in the description box. So if you want to do hands-on, you can do that, and also I will attach a GitHub Repo link where all the files will be available, so you can do hands-on from your own if you want. So that's all for today. See you in next video. Thank you so much.